Hi everyone, I'm Vikrant and I welcome you back to my YouTube channel Cornerstone. So in today's video, we are going to build the machine learning model, not in Google Colab, not in Jupyter Notebook, but within the Excel itself. As you know that now Python has been integrated into the Excel and this will become available to all the Microsoft users in a gradual manner. So we can use the powerful Python libraries such as Pandas, Scikit-learn, NumPy, Matplotlib, Seaborn, etc. in the Excel directly. Okay, so in today's video, what we are going to do, we will use the Kaggle website to download the student performance dataset and the topics which we'll cover today: how to define the data frame using the pandas. Then using the pandas, we'll perform the data wrangling technique in which we will cover data cleaning, remove duplicate rows, we'll perform the string replacement, and we'll handle the missing items. And also will perform the descriptive statistics as well. So for those people who are new to my channel and are not familiar that how we can use Python in Excel, so I already have created 2 or 3 videos on Python in Excel. So I would recommend you guys to please go through those videos and make yourself familiarized so that this information can be get easily digested. Okay, the fourth topic which we'll cover is the data visualization, right? So EDA, exploratory data analysis, where we will use the box plot, heat map to understand the correlation between the dependent variables and the independent variables. Okay, and we'll perform the split 70 to 30 ratio, test and train, and use the linear regression algorithm to predict the values, and we'll compare those predicted values with the actual values, and we'll see that what is the accuracy score of our model we are achieving in the end. Okay, using the R2 score, right? So that's all guys, that are the topics which we'll cover in today's video. So the first thing is first that we need to make ourselves familiarized and comfortable with the data set which we are going to use, right? So directly jumping onto the Kaggle website. So here you can see the student performance dataset is a dataset designed to examine the factors influencing the academic student performance. So it consists of 10,000 student records, with each record containing information about various predictors and a performance index. Right, so predictors here, the variables, 5 variables, right? So x1, x2, x3, x4, x5. So these are my independent variables. X1 is the hours studied, the total number of hours spent studying by each student, right? And the previous scores, the scores obtained by students in the previous tests. Extracurricular activities, whether they have participated, yes or no. Sleep hours, the average number of hours of sleep the student had per day, and the sample question papers practiced before they have given the final exam, right? The number of sample question papers the student practiced. Now my y is the target variable, which is the performance index. So basis the independent variables, we would like to see how it's going to impact our dependent variable, my y performance index, right? Let me quickly jump on to the Excel spreadsheet. I've already have downloaded this data. So this is how actually it looks like. Our studies, so it's a continuous variable, right? We have the previous scores. Extracurricular activities, this is the categorical columns. We have the responses available in the form of the binary, yes and no. Sleep hours, so in 24 hours per day, for how many hours the student has been slept. Simple question papers practice 1, 2, and so on. And the performance index, so this is the final score they have achieved, right? So this is my project Y, and from column A to column E, these are my project X. Okay, so first thing is first that we need to create here the data frame. So is equal to py, and just provide here the range of the data table. So as we know that we have like 10,000 records here, so we have already given the range here, and I'm going to store this information in my df. Okay, and then control enter, and you will see that the data frame will get created here as an Python object. So let me scroll it back to the top. It's busy. Yeah, data is huge, so that's why it's taking time. Yep. Okay, so now we have the data frame. So data frame, you can see that we have the columns, we have the rows, and we have the 0, 1, 2, 3, 4 up to 999. So these are the index position number. So let me convert this data frame into the Excel value, right? So This data frame is nothing but this is completely a transformation of your data table to the data frame so that we can use the pandas library here to interact with the Excel. Okay, so the next part is that I would like to know here that what is the shape of my data. So for that I can use df.shape and hit the control enter, and this will return me the tuple, and in tuple you will see the Excel value. And in Excel value you can see 10,000 are my number of rows and 6 are my number of columns. Now the next ask is that I would like to know that what are the number or the count of total missing items in my data frame. So for this again is equal to py, and then df dot is null, and then sum, right? So this will return me a series, and in this series this will give me the information about the column name and the number of values that are not being filled in the data frame. So for our study it's 2 count, for previous score 8, and then extracurricular activities yes or no 13, and so on and so forth, right? So what if I would like to know that what is the total number of values which is not being filled in my data frame. So I can just simply use again here a sum, and in totality I will get one number, that is 38. So 38 cells are not being filled, or 38 values are missing in my total data frame. Okay, so the next thing is that I would like to take a call here that what I need to do with these missing items, whether I would like to use certain method in order to fill that, or I would like to drop, right? So in my scenario, in this particular example, I'm going to drop these NA values. So how I can do this is equal to py, and then using the df dot drop NA, and then what method I'm going to use is equal to how and NA. So the how is equal to any, this method will check for each particular row in your data frame, and even if a single cell or if a single value is missed from a particular row, it will go and delete that particular one. Okay, so I'm going to use here the method how is equal to any, and we are going to store this information back into the df1, a new data frame, and let's hit on the control enter, and this will return me a new data frame. Now in this data frame, if I convert it into the Excel value, you will be able to see all the data filled. There will be no gaps in between the data. Okay, perfect. So if you would like to get rid of these index positioning number, in the end you can mention here dot reset underscore index, and then drop is equal to your true. Perfect. Now you will not be able to see the index positioning number. See, you have the 5 x1, x2, x3, x4, x5, your independent variables, and performance index your target variable as y. Perfect, right? So as a next check, I would like to see whether there are any duplicate records in our data frame or not. So for that, what we can do, we can use here is equal to py, and then data frame 1. This time we are going to use the data frame 1 df1, and then duplicate it, and then type here sum, and this will return me the number of rows which are duplicate. So 124 are the number, 124 is the number which is duplicate, right? So if you would like to see specifically those records which are duplicate in your data frame 1, so you can use here is equal to py, and then df1 is my data frame, and starting the square brackets here, and then using again here df1 dot duplicate it, and closing the square brackets and hitting the control enter. So this will return me a new data frame which will hold the 124 duplicate rows. See the number of the records 124 here. So these all are duplicate rows in my data frame 1. So now if I want to get rid of my duplicate records from the data frame 1, so what I can do, I can just create an use the Python function here, and I'm going to define a new data frame which is called as the df2. Now in this df2, what I'm going to store only the unique records. We are just removing these 124 duplicate records. Okay, so in order to achieve this, df1 then drop duplicate, and from this df1 dot duplicate we are resetting the index, so we do not want the index positioning number, and drop is equal to true, right? So that's the line of the code. Okay, hit the control enter, and this should return me a new data frame which is named as df2. Hit on the Excel value, So guys, in df2 we do not have any duplicates available now. Okay, these all rows are unique, and that's the reason you can see that now 9858, we started with the 10,000 rows, now we are left with 9,858 rows only. Okay, so till here we are good. So now let's say if you would like to see for the unique values each column actually it holds. So let's take an example of the sample questions they have practiced before the exam. So in order to achieve that, I can use here is equal to py and then my df2 and passing here the column name. So I've stored the column name here, sample questions papers practiced, and then utilizing it here and then using here the unique. Okay, so this will return me a array. Yeah, it's taking time because guys, whenever you use the Python function, it will go and do all the retrospection. It will all make all the calculations available to you. So it's starting from the very beginning, the data frame. So that's the reason sometimes it takes the time. And this is one of the limitation as well, that the Python in Excel, it actually works in the online mode only, right? So if you stop your Wi-Fi or if you disconnect the internet, you will get the errors. Your Python in Excel will not work for you. So this is one of the thing. Maybe Microsoft will fix this in the later release. Perfect. So we got the array here 12560349778. So these are the total 10 unique values that has been stored in the sample question papers practice. So what if I would like to see in totality that what is the count? I am not interested in the values. So for that, you can just use here n as a prefix to the unique and then hit the control enter and you will see the 10 only here. Perfect. So 10 is the unique value that has been used in the sample questions paper practice. Perfect. Guys, one more thing I would like to talk about here is that we have the only one column, the extracurricular activity, which is into the categorical form, either yes or no, binary form, right? So if I would like to see that what is the frequency of the yes and what is the frequency of no, so I can do this by using the df2, sorry, is equal to py, and then in my df2 in this data frame, let's use the extracurricular activities, the column name here, and closing this down and then using the value and counts. Okay, so this will give me the frequency. So for yes, how many number of counts? For no, how many number of counts? Okay, so it, let's convert it into the Excel into values. See, for no, we have 4979. For yes, we have 4879. So guys, one thing that machine learning, it understands only the numbers, right? So it doesn't understand whether red color is good or whether blue color is good, whether yes is good or whether no is good, right? So we have to transform this no and yes value to some numerical form, right? So there are certain techniques in the machine learning, but I will not go into the nitty and gritty in this particular session. But yes, as of now, just to make it simple, for yes we will use let's say 1, and for no we will use 0. Okay, so we need to replace the yes and no in the extracurricular activities. So how we can do this? For df2, sorry, is equal to py, and then in df2, this is my particular column. I would like to replace this column, so I'm again using the df2 and then passing here the extracurricular activities. Let me just expand it a bit to make it easy to understand. So df2 and then your column name extracurricular activity, which is a categorical variable, then is equal to df2 extracurricular activities. So this is the particular column which we would like to replace. So replace here is the helping thing, right? The function you would say. Okay, so for replace, I'm just closing, just starting here the brackets, and inside the square brackets for no and for yes. So what values I would like to give to no and yes? So for no, we have decided that we will give 0, and for yes we will give it 1. Okay, perfect. And then we are closing it. All right, so this should resolve our problem. Control enter. all the back all the back calculations has been performed. Now we got the none type here, uh, so nothing to worry about here. Let's test whether it has been replaced or not. So with the help of the df2 we will get to know. Is equal to py, and then we are just pressing here the df2. Let's see. We got the data frame. Yep. See guys, now the extracurricular activities. So for the yes has been replaced by 1 and no has been replaced by 0. Now the entire your independent variables, 5 independent variables, they are into the numerical form, right? So now it becomes easy to move ahead, one step ahead, and start with the exploratory data analysis, right? So where we will create the box plot and the heat map to understand the independent variable impact on the dependent variable. All right, so let's move to the next phase of this video. Yeah, so df2 is the latest data frame which we have created. Now with the help of the df2 we would like to see the descriptive statistics of our data frame. Okay, so is equal to py and then df2 dot describe. Control enter. This will return us the data frame, and I'm converting the data frame into the Excel value. So with the help of the describe, we would be able to know the data count, the mean, standard deviation, minimum and the maximum value, your range, 25th percentile, 50th percentile, and the 75th percentile. Okay, so this gives all the information, the descriptive information about our data frame, right? So for hours studied, the count are 9858, and across all particular column the count is same. Okay, and mean is 4.99 for hours studied. For previous score it's 69.43, so mean is something which is the average of all the data values. Standard deviation is 2.5, and so forth. And for hours studied, the minimum value is 1 and the maximum value is 9, and in between minimum and the 25th percentile the value is 3. And you can see that in the previous scores, the maximum value is 110 and minimum value is -10. And for the sleep hours, the minimum sleep hours is 4 and the maximum sleep hours is 48. So we can clearly see that, guys, there are some outliers in our data frame, right? Because in a day, a person cannot sleep more than 24 hours in a worst scenario. So but it shows me that the maximum value is 48. So this implies that there are outliers available in our data, and we need to see the spread of the data. Okay, and from this one, as the maximum score is 100, so a student can get the one score up to 100 score, the maximum, right? So it's not the scenario that the threshold can be get breached, so no student can get more than 100 points, right? In the same manner, for the performance index, the maximum score is 180, which is not the right case. So there are outliers which is available in our data. So in order to see that, how our data spread actually it looks like, so first of all we will use the histogram. So histogram will help us in finding the the frequency distribution of each particular column. It will help us in finding the approximate center, your shape of the data, your spread of the data, whether it's left squared, whether it's right squared, right? So how we can perform this is equal to py, and then we are again using the df2 dot hist. Okay, and then control enter. So this will return us an image. Yeah, and in order to see this image, I'm just merging few cells here so that we can see all the visuals in one go, and then clicking on this option to Excel value, and this will return all the information in the terms of the frequency distribution, right? So in, yeah, let's wait for it. So you can see that for our studies the frequency of the it's quite distorted, but yes, on the high level you can see that okay, how the data spread actually it looks like, where is the center of the data, whether the outliers are available or not. Just to make it simplify, guys, let me give you one example here. So we use the box plot in order to see the spread distribution of the data, and where does your median stands and what is the IQR value, right? So in the box plot, what we can do, let me, sorry for my bad drawing here. So here it is the maximum value, here it is the minimum value, and then this is the median. Okay, this is my median, and this whole range, this is my IQR. Okay, so IQR is interquartile range. Okay, and this point is your Q1, this point is your Q3, right? So Q1 is your 25th percentile, and then Q3 is your 75th percentile. Okay, so now whatever the values which is going beyond the minimum, let's say we have the values here, right? So and we do have the values in the maximum segment as well. So these are my, these both on the minimum side and the maximum side, these are my data outliers. Okay, these are my outliers. Okay, now how do we calculate whether these are the outliers or not? So for this, Q1 is your 25th percentile. So in order to see that what value should come in the minimum, there's a statistically defined formula for that. So it's Q1 minus your 1.5 times of your IQR. So that's the formula, guys. To in order to calculate the minimum, Q3 plus 1.5 times of your IQR. Now what is IQR? So IQR is the Q3 minus Q1, right? So IQR is equal to Q3 minus Q1. So whatever the value which is going beyond the minimum and above the maximum right here, so these all are my outliers, right? So how to treat the outliers, there are different methods, right? So sometimes it gives you the real picture of your data as well, and sometimes if your maximum value, in our case, in the student performance, as we know that none of the student can go and score more than 100 marks, right? But in our data we have seen that 170 or 180 or people, they have scored like 100, more than 100 score as well, right? Which is not right. So in our scenario we have to remove the outliers. Okay, so for the box plot, we need to first of all import the cborn library. So import cborn as SNS and then SNS dot set. Now we are setting here the figure size. So RC is equal to, then we need to start the curly braces here, and then figure dot fixed size, and then closing this one, and the limit which we are giving is 20 and 15. All right, okay, and then SNS dot box plot, and the data frame which we are going to use is the df2, right? And that's the line of code, guys. Okay, so I'm just clicking here the control and enter, and then let's wait. It's showing us busy. So now Python and Excel will go and start the Excel calculation from the very beginning. You can see here it's giving us the icon of the refresh. Now till descriptive statistics is being done, we have the df2.hist as well. So histogram is also available. Let merge few of the cells here so that the image appear clear to us. Okay, merging the cells here and Excel value. Okay, now the box plot will tell us the Q1, Q3 and the median and the min and max and the outliers. Okay, yeah, perfect. So basis the box plot diagram here, you can see that the previous scores and the performance index, the values are coming in the negative as well, right? So you can see here these dots. So these are the outliers in my data because numbers cannot be negative. and even the students, they are getting the scores more than 100 as well. So I believe these are the data typing mistakes done from the admin side or done from the teacher side, but this is not the ideal scenario. So we are going to delete all those numbers which are in the negative one, and those numbers those student records who have scored more than 100 marks, right? So these seems are data typing errors. And for the sleep hours as well, the scores are more than 24, so which is not also not accurate, right? So these three columns, previous scores, sleep hours, and performance index, right? So let's open the notepad here, and the name should be exactly same. So I already have copied it here. So previous score, the range should be 1 to 100, sleep hours 1 to 24, and performance index 1 to 100, right? So let's write the line of code here to remove or the records which are not falling in this limit. Okay, so for that is equal to py, and then df2 is the data frame, and in df2 let's start with the very beginning, the previous scores, and then previous score is my column name dot between, right? So in between, the numbers should be 1 to 100, right? So number should not be negative, and numbers cannot be more than 100 as well. Okay, in df2 and this one, and I'm storing this information in df3. Perfect. For the next column, that is the performance index, will do the same exercise here. Okay, and the condition is going to remain same, the number condition. And for the third one, that is our sleep hours, we are going to use the condition from 1 to 24. So just copying the column name here and storing it here and changing the condition. So number should be in between 1 to 24. So first of all, we have stored this information previous scores into df3, and then we are making some tweaks here. So we are going to use here the df3 and then df3, and we are storing this back in df4, and then we're using here df4 and then df4, and I'm calling it df5, and then in the end I would like to see here my df5 shape. Okay, so df5 dot shape. Perfect. Let's review the line of code. df3 is equal to this one, df4, perfect, and then we have used df4 and stored this information in the df5 and df5 dot shape. So guys, you remember that till df2, when we have done the descriptive statistics, we were left with like 9858 records, if I am not blanking on that one. So we will see that how many records now it has been, removed from this section. So control and enter will get the new data shape here. Yeah, just wait, it will give us back the tuple, and then we need to change it to the excel value. Yeah, so 9858 was the number of rows till the part of the df2 when we have checked it in the descriptive statistics. Now basis the Okay, now basis removal of the outliers, we are left with 9843 rows and 6 columns. Okay, let's check the before and after position by just copying and pasting the same Python code here. So we'll see the box plot difference, whether there are outliers still or not. Okay, so is equal to py, and then copying the same line of code here, just changing here the data reference to df5, the latest data frame, and control enter. So now we will be able to see the before and after comparison. Okay, we got the image. Let's merge few of the cells. All right, convert it to the excel value. We'll be able to see the difference. Okay, okay, so This is my pre and this is my post. So you can see that outliers has been removed. Now the data is falling into the right place and we do not have any outliers in the data, right? So that's the purpose of the box plot. It helps us in removing the outliers. It helps us in checking the data spread, whether the data is left squared or right squared, and etc. Right. So now we will move towards the another portion, that is the heat map. For the heat map, we'll use the plt dot figure, and then fig size is equal to 1512. sns dot heat map, we are going to use the cbond library again, and df5, which is the recent data frame after the removal of the outliers, and then dot correlation, and the data annotation is equal to true, and cmap, we'll use the very basic code here. Let's go with red, yellow, and green, and that's it. Hit the control enter and merge few of the cells and convert the image back to the Excel value. Just wait for some time, because now all the backend calculation will perform first and then we will be able to see the heat map. Okay, so we got the histogram, we got the box plot, and here is the heat map. Perfect. So here you can see that the hour studied is my independent variable project x1, and the performance index is my project y, the target variable, and 0.38 is the value, which shows that there is a positive correlation between the performance index and the hours studied. For the previous course and the performance index, the value of 0.92, it signifies that they hold a very strong positive relationship, right? However, for extracurricular activities, sleep hours, and simple question paper practice, the values are not very significant. So we can think of dropping these values from the train and split model here, from the linear regression problem, right? Just to avoid the curse of dimensionality and the model overfitting. Okay, however, previous score is very important, and then the second important is the hour studied. Okay, with that we will move to the last phase of this video and we'll start building the model. Is equal to py, and then we will use the sklearn library. So from sklearn dot linear model, import linear regression, and then from sklearn dot, we'll use the metrics here. So from metrics we'll import the R2 score. Okay, so R2 score, in order to check the model accuracy, R2 score, and then from sklearn dot model selection, we'll import the train test split mode. Okay, now we'll define here the x and y. Okay, so for x and y we'll use here the df5, which is the recent one, the data frame which we have created after removing the outliers, right? So for df5 we will drop here a few of the columns as we have decided, which does not add any value in our model. So for that, what we are going to use here, df dot drop, and we will specify here the columns name. Okay, so I already have copied these columns names. Okay, so the columns extracurricular activities, sleep hours, sample question papers practice, and the performance index, as you know that this is our target, the variable y, right? So we are dropping it from the x. Okay, so now performance index, and then using here the x is equal to 1. Perfect, and we need to close it. For y, we are going to use here only one variable, which is the project y and the performance index, right? Okay, so now we have defined the x and the y. Now we need to do the model train and test split. Okay, so for that, first of all, x train, then your x test, and y train and y test, that is equal to your train test split and x y is small, and then random state is equal to 0 and test size is equal to 0.3. Perfect. So 70% that will be utilized for the training purpose, and 30% of the data will go into the testing purpose, right? So that will be total random based. We do not have to do anything in between. Okay. Now the next part is we'll use here the LR for the linear regression, right? So this is my linear regression, right? And the next part is that we would like to fit this LR, the linear regression model, to fit the X train and the Y train. Okay, and we will predict here the value and store it in the Y pred. Y pred is equal to LR, linear regression model we are utilizing here, and we will predict the X test, whatever the value there are in the X test, that we will predict using the linear regression model, and in the end we will use the R2 score in order to measure the results. So whatever the Y test value and the Y pred value, basis on this we would like to see the R2 score. All right, let me QC the code here. We are using the linear regression, so I believe there should be this one, linear regression. So from sklearn linear model, I think that is okay, and let's uh, use the control enter and see the model accuracy we are achieving. Perfect, fingers crossed. Let's see. Now all the backend calculation is performing, so it may take time because now the model will start executing from the number one stage. It will start with the data frame, then we'll remove the duplicates and whatever the steps which we have used in the data wrangling, and then the data exploratory analysis. You will see here the histograms, box plot 2, and the heat map, right? So that's why it's taking time, because there are n steps which Python will do before the model building. Or we are almost there, guys. So see, we are getting here the model accuracy is 98.5%. So guys, 98.5% R2 score, it means that your actual values, which is in the DF5, the data frame 5, and the predicted values that we will get with the help of the linear regression model, that will come very close, right? So that's a great score. Now that's the last code which I'm writing in this video. So is equal to py, and with this line of the code, what we are trying to prove here, that the actual values in the DF5 and the predicted values using the linear regression, are they true or not? Are they close to each other or not? So let's see with this particular line of code. I'm converting the data frame into the Excel value, and now you will be able to correlate that the R2 score of 98.5%, how close it's giving us the result. Okay, so it will take some time because yeah, so here we are. So here you can see, let me just make it on the same scale. So actual value is 88 and the predicted delivery or the predicted score is 85, right? So 24 and 23, 79 and 78. So there's a difference of like maybe plus or minus of 1 or plus or minus of 2, but else the numbers are coming very close. So we have solved this student performance problem using the multiple linear regression problem, right, in Python in Excel. So with that, I take a pause. I hope you have found this video useful and content informative, and if you have learned something new today, please consider pressing the like button and subscribe to my YouTube channel for getting all the upcoming videos notification on time. I see you in my next video. Till then, take care. Bye bye. Thanks for watching.